Welcome, Chem 1. Today is the beginning of Unit 5, and we're going to take a look at the history of the periodic table. Let's get started. Some elements like gold, silver, lead have been known for centuries, going back a long ways. But we really didn't start to organize those elements into the table until the late 1700s. We started to discover electricity, which allowed us to kind of split elements into their pure forms, which started the process of scientists trying to organize the elements by physical and chemical properties. From 1790 with Lavoisier to the 1870s, which is about an 80-year period, we went from 23 known elements all the way to 70. This is a picture of Lavoisier. He was the first one to try to organize these elements. In 1829, more and more elements were being discovered, and Dobereiner discovered that certain elements had similar properties to one another. They had the same properties, and they also seemed to be separated by the same differences in mass. So now that everything's organized in the periodic table, it's a little easier to see. But you can see how lithium, sodium, and potassium, they're in the same column, which means they have the same properties. But we can also see that from 7 to 23 is about the difference of 16, and then from 23 to 39, which is the mass of potassium, is also the difference of 16. This happens multiple times on the periodic table, and that's what Dobereiner was noticing. We call this Dobereiners Law of triads. Then, several decades later, John Newlands noticed that these patterns of properties kept resetting every eighth element, and therefore he called it the law of octaves. So if we start with hydrogen and work our way across the periodic table, he noticed that instead of fluorine fitting here at the end, it fit closer to back here at the beginning. You'll notice that there are some elements that we line up in a column that are different than what they knew back then. That's because there's a lot of things we understand now about electron configurations and the properties of those things. You'll also notice the absence of noble gases. That's because a lot of them hadn't been discovered yet. Gases are really hard to discover because they're kind of like atmospheric and difficult to produce. One big reason that Newlands was able to accomplish this was because in the 1860s there was a new method for calculating the mass of an element. Then we get to Meyer, who is probably one of the more forgotten scientists when it comes to the periodic table. He worked at the same time as Mendeleev, who usually gets all the credit, and Meyer actually came up with a very detailed table for how to organize the elements. He organized the elements based on the mass of those elements and the properties of those elements. So he ordered them by increasing mass, and then he put them in columns when they had similar physical and chemical properties. This is a representation of one of the first periodic tables that Meyer developed. It doesn't look very similar to what we have today. He's still missing things, but you will notice that they're grouped by mass and properties. You'll also notice that in his table, things worked horizontally. So if things were in the same row, that meant they had similar properties. You can see that this lithium, sodium, potassium row is the first column of our current periodic table. Now we get to Mendeleev. Mendeleev typically gets most of the credit for the periodic table. Why is that? What Mendeleev did was organize just like Meyer, but he left gaps. Mendeleev left spaces in his periodic table where he believed there were elements yet to be discovered. And not only did he say, hey, there's an element there that we haven't discovered yet, he also predicted the properties of that based on the trends across the periodic table or down a column or across a row. That is the brilliance of the Mendeleev periodic table. It's not just that he organized the elements, it's that he predicted what we should be looking for in these undiscovered elements. That's why Mendeleev gets most of the credit. As we stated earlier, you'll notice that the noble gases were not discovered yet, and therefore they're not part of Mendeleev's table. One thing that we've improved on Mendeleev and Meyer's periodic table is that it's not organized based on mass anymore. Mendeleev and Meyer didn't have this knowledge, but we know now, based on the research of Moseley, that what defines an element or defines an atom of an element is the atomic number or the number of protons within the nucleus. So this is how we currently organize the periodic table. Even though organizing by mass will get us close to the correct order, there are some elements that would not be ordered correctly based on Mendeleev's periodic table because it's not organized by positive protons. So the modern periodic table, or the modern periodic law, organizes in families or groups vertically. based on physical and chemical properties. That's similar to what Meyer and Mendeleev did. And we know now that the reason they have similar properties is because they have similar electron configurations. Everything in the first column has similar properties because they have one valence electron in that s sublevel. We also organize the periodic table in horizontal rows called periods. A period or a periodical is something that repeats over time. And so the pattern when we get to the end of a row will start to repeat, which is why we put the next element back in the first column. So remember, families or groups are vertical columns, and periods or series are horizontal rows. That's really all I wanted to cover today with the history of the periodic table. Hopefully that gives you enough background that we can start going through the trends of the periodic table and how to identify them. Good job. We'll see you